All right, well, hello everyone, good afternoon. Welcome to the April edition of the NOAA West Watch. We are a little bit past 2, and so I think hopefully some others will trickle in, but I'm gonna go ahead and get started with our webinar today. I always like to do a little background on the West Watch for those not familiar with it who need a refresher. So this is a monthly webinar series that brings NOAA staff and partners, university partners, other partners to share information about climate observations, ocean observations, and the impacts we're seeing across the West. The webinar series has 2 formats. Today we have the general climate overviews, which provide the terrestrial and atmospheric overviews, and then also an update from our IUS partners on the oceanic conditions. And then the second format is on specific topics, and so we alternate those every other month. And some of the topics we've seen recently have been things such as atmospheric rivers, marine heat waves, wildfire, and so those are more focused webinars with experts on those topics. A little housekeeping before we get started. I think we're going to have a poll come up here in a second, and hopefully the audience can take a minute to answer that. That should be up on your screen now. And the question is, have you attended West Watch previously? And yes, everyone on today has attended, so thank you for coming back. I think we have a smaller group, so I appreciate everyone coming back today. Let's see, why is that showing? Okay, so as speakers are presenting, you can enter questions you have into the questions box on the right-hand side of your control panel. And then if we have time after each speaker, we'll have a brief Q&A and then hopefully a little time for discussion at the very end. And these are recorded, so you will be able to go to the West Watch website not long after this webinar and view the recording if you would like. And then as always, we appreciate your feedback as you will get a post-webinar survey. Today, again, we have the general climate and ocean format today. So I'll be giving the regional climate briefing, and then we'll have our 3 partners from IUS. We'll have Roxanne Carini from NANOOS, Alex Harper from CeNCOOS, and Clarissa Anderson from SCCOOS. So I'm going to jump right in and get started with the climate update and outlook. And I'm going to start out by talking about our snowpack a bit. And this is a somewhat recent photo from the Central Sierra Snow Lab on a field project that I'm working on, looking at snow temperature profiles. And this was early March, and that is a pretty deep snow pit. We needed a ladder to get to the top. But believe it or not, that's close to average for that particular location in the northern Sierra Nevada, maybe a little bit above average. So we'll talk about where we're at with snowpack. And typically in the western US, the snowpack tends to peak late March to maybe mid-April, and so we're right around that peak snowpack or past it for a lot of places around the West. And so this is a map from the NRCS SNOTEL network, and this is showing the Huck 6 watershed basin snow water equivalent average for each basin. And so the snow water equivalent is the amount of snow that is in the snowpack if you were to melt it down, and it's really the most important part of the snowpack for water supply and understanding our water supply forecasts. And so these colors indicate, so the blues and greens indicate an above normal snowpack for the date, which was April 14th, just a couple of days ago. And then the browns, yellows, and reds indicate below normal snowpack for this time of year. And so what we see here is that there's a pretty cohesive pattern where you have most of Washington, northern Idaho, most of Montana, and northern Wyoming in those below normal shades, with some areas, less than 60% of normal SWE for this time of year. And so this has been persistent for most of the season for this area. It's been, and I'll show some anomalies, but it's been warm and dry for a lot of these areas. And then you look over the rest of the West, and it's in, most areas are in pretty good shape. Above normal, there's some blues and some darker blues above 150% of normal. So it's good to see that outside of those areas in the northern tier, most of the rest of the West has a pretty good snowpack right now. But I did want to talk a bit more about those areas that are in snow drought or have that below normal snowpack. And so this is on the top right is another map showing the individual SNOTEL stations. And the ones that are colored in that darkest dark red color is record low snowpack for this time of year. And the other color that's on there, the orangish color, is the second lowest on record. And so this is really highlighting that these areas aren't just below normal, they're kind of out of in uncharted territory for some of these locations, particularly in western Montana. There's a few areas in Washington also that have record low snow water equivalent for this time of year. And then second lowest also into Idaho. And so I'm showing on the bottom left there a trace of the how the snowpack has accumulated throughout the season for Stewart Mountain, Montana, which I've circled one of those record low snowpack locations. And the black line is showing this year, and then that green line is the historical or the climatological average or normal for that period. And so this was showing this particular location, it was at 62% of normal, but it is record low. It's below that bottom red line, which was the previous lowest on record. And it's actually below by quite a bit. And so this is a pretty bad scenario in terms of being able to go further into drought and also impacting the spring and summer water supply and also wildfire as we get later into the year. And really, spring precipitation could help this region, but not so much with snow, really that much more this time of year. And really, we hope we don't see the worst case scenario, which is that trace would continue down below the red line and would melt out really early, over a month early if that happened. And so not a great situation for snowpack and drought and water supply, and will likely have impacts going into the summer for these areas. And so I wanted to describe some of the anomalies, temperature and precipitation that have sort of driven this pattern of lower snowpack in some areas. And these are two maps on the left, or they're both temperature percentile rankings from the West-Wide Drought Tracker. And I split the 6-month period, October through March, into two halves because there's kind of some distinctions that stand out. On the left, we have the October through December, so the first 3 months of the water year, and then on the right, we have January through March. And so on the left, we see, almost all in that red-orange shading, which is above normal temperatures. But we see quite a bit in that much above normal top 10% shading, and even in a few areas of record warmth for that 3-month period, but really just warm across the entire West. And then on the right, it is toned down a bit, but it's still mostly in that above normal shading, but not nearly as warm as it was during the first 3 months. And we even have some areas of blue, which is nice to see in the Sierra Nevada, Arizona, Southern California that were a bit below average for that 3-month period. But the thing that kind of really stood out when you separate the two 3-month periods is the precipitation anomalies. And so this is the same maps, but for precipitation rankings. And so this water year started out really dry for the Southwest, the Sierra Nevada, much of Arizona. Also, again, that Western Montana, Northern Idaho, and Washington Cascades. But then in the January through March period, things flipped quite a bit for the Southwest. Things got a lot wetter. There was a lot more storm activity going through the southern tier of the West. And so a lot of areas there were above normal or even in that top 10% of all years for that 3-month period. But the circles there that I highlighted have really stayed dry this entire water year, and that's really contributed to that below normal snowpack. And on top of that, the above normal temperatures have also contributed to that really low snowpack that I was showing before. So I wanted to move on and talk a bit about the water supply or the runoff forecasts, which is heavily impacted by the amount of snow that's in the mountains. And so this is from the NRCS, similar to the snow map I showed, but this is now for each basin, it's the April through July runoff forecast as a % of normal. And so not really unexpectedly, we see those areas that had the low snowpack, Washington, Montana, northern Idaho. The forecast there is for below normal runoff, anywhere from about, 65 to 85% of normal snowpack. I'm sorry, runoff. But something that was a bit unusual to see was that parts of the upper Colorado and Rio Grande are also showing below normal runoff for that period. And if you recall the snow water equivalent map I showed, all those basins have above normal snowpack right now. And so there's some questions about why that runoff would then be below normal. And I'll dig into that a little bit here in a minute. But I also did want to show this. So this is from the US Bureau of Reclamation. They put out this report every week, once a week, for the lower Colorado water supply. And just really emphasize that despite having now 2 years in a row of good snowpack in the Colorado River Basin, there's still this long-term drought and water shortage issue in the Colorado River Basin. Lake Mead and Lake Powell are still, just barely above a third full. And that issue I was talking about, the reclamation forecasts are also predicting below normal runoff into Lake Powell for the April through July period, 89% of normal. But you'll notice the March inflow was just 76% of normal, and the April forecast for the whole month is 78% of normal. So I wouldn't be surprised if these numbers actually go down in terms of the seasonal outlooks. And one thing that might be driving these below normal forecasts are the antecedent conditions that really impact the runoff efficiency and how much of the snowmelt goes directly into the streams and reservoirs versus how much goes back into the soil to moisten up the soil. And so this is a map from the soil moisture percentiles from the fall before a lot of the snow fell. Early November, and we see that it was really dry. The land surface was really dry around that Four Corners area, the parts of the upper Colorado River Basin. And so this is likely one of those contributing factors to those below normal runoff forecasts. And there's probably some other factors, but I'm not exactly sure what is driving those below normal forecasts other than these antecedent conditions were really dry. And we have seen this in the past decade where we've had above normal snowpack, and that does not translate into above normal runoff every year. And all this is going to contribute to the drought conditions as we move into the spring and summer. So the map on the left is the latest US drought monitor that was released last week, showing the drought conditions. And the areas that were in snow drought are, for a large part, do have the most drought conditions in Montana, some severe drought, moderate drought, a bit in Washington. I did just see today that Washington State is declaring a drought emergency for just about the entire state, starting, I think it was today. But there's also lingering long-term drought in the Southwest with that D3 and D4 extreme and exceptional drought in parts of southern New Mexico. And then on the right is the seasonal drought outlook, which tells you about how those categories might change going over the next 3 months. And so, not surprisingly, the drought is expected to persist in Montana and Idaho, parts of the Cascades, and also the Southwest. But there are some expected improvements in Arizona and Wyoming and very far southern Montana. So with that, I wanted to move on to the ENSO update and then the seasonal outlook. And so a lot of this is directly from the Climate Prediction Center updates that come out once a week, and this was from Monday the 15th. And so officially we are still in an El Nino, and there's an El Nino advisory, but there's also a La Nina watch ongoing right now, and we'll look at the forecasts to see why that is. But if we look at the map of the ENSO region that I've highlighted here, we can clearly see that El Nino is waning, and even in the eastern part of the region, there are some below normal sea surface temperature anomalies, and the magnitude of the above normal anomalies has gone down quite a bit. Yeah, according to the CPC, the El Nino is likely to transition to ENSO neutral by, there's about an 85% chance during the April to June period. And the odds of La Nina redeveloping in June to August, there's a 60% chance of that happening. And just to emphasize more on the weakening of this event, this is also from the CPC. This is showing the time series of each of the Nino regions and how they've evolved since, I guess this is about a year ago. And we can see that pretty much everywhere the El Nino has peaked and the sea surface temperature anomalies are declining. The Nino 3.4, which is the primary index used to quantify La Nina and El Nino events, has fallen to below 1 degree C, and that Nino 1.2, which is that eastern region, has dropped to negative 0.2 in the latest weekly anomaly. So the event is weakening. And now on to the ENSO forecasts from the CPC and the IRI. And these are a couple different ways to look at this. The top left is showing the probabilities of El Nino, La Nina, or neutral conditions for each season. And if we look at the first season, March, April, May, we still have that above 90% chance of being in El Nino, but that quickly falls off. By May, June, July, we're at a 70% chance of ENSO neutral conditions. And then as we get out into the summer, the odds really ramp up to a greater than 80% chance of La Nina conditions developing by late summer into fall. And the bottom right is just showing the individual models for each season, and you can see the spread. And so there is some spread, but pretty much every model shows that decline in the Nino 3.4 sea surface temperature anomaly with varying magnitudes, but almost all show that return to La Nina conditions by late summer or fall. And I wanted to show a bit on the seasonal outlook. I typically show the CPC probability maps, but those aren't going to be released. The latest ones aren't going to be released. It might be this Thursday or next Thursday. But what I'm showing here is the North American Multi-Model Ensemble, which is one of the main inputs that the Climate Prediction Center uses in their outlooks. And these were released earlier this month. And so this is showing the May, June, July probabilities of above or below normal temperatures on the left and above or below normal precipitation on the right. And for temperatures for May, June, July, there's pretty strong odds from the NMME indicating above normal temperatures likely. A little bit along the Southern California coast, the odds are much lower or not showing above normal temperatures or near normal, but everywhere else has pretty high odds of above normal temperatures. And for precipitation, there are some hints of possibly above normal precipitation in the northern Great Basin into parts of Montana, which would be good for that region, but some stronger probabilities of below normal precipitation for New Mexico and western Colorado, which would not be great given what we saw with the runoff forecasts and the drought conditions there. And finally, we're getting into the start of fire season for some locations. I know it's still early, but I did want to start talking about the significant wildland fire potential outlooks. These are produced by Predictive Services, and these maps just simply show the outlook for above normal, below normal, or normal wildland fire potential. And so this is based on what is climatologically normal. And so this shows whether there's a chance of more fire activity than normal or less fire activity than normal. And so the outlook for May is on the left and June is on the right. And climatologically, Arizona and New Mexico are one of the first places in the western US to ramp up in terms of when fire season begins, and that can happen in May and June especially. And so in May, we do see the reds, which is above normal potential for parts of Arizona and New Mexico. And I also want to point out Hawaii, which is all shown in red. I don't have a lot of information about what's driving that. I know it's been pretty dry there, but interesting to see that it's above normal for all of Hawaii. And good to see some greens in California for below normal potential. Also into June, especially in the higher elevation where the snowpack is good in the Sierra Nevada and also along the coastal area. So that's good to see for California. And then as we move into July, the patterns change a little bit. There's still above normal potential for southern New Mexico, but that above normal potential expands into the northern Great Basin. And this could be driven by the wet conditions, and a lot of the fires in the Great Basin are more grass-driven fires as opposed to timber fires. And so that could be driving some of this with potentially a lot of grass growth over the past 2 wet years. But still seeing below normal potential in the Sierra Nevada and parts of coastal California, which is good. As these progress through the summer, you know, the update to the July or the August and September outlooks, I would expect to see some more red showing up in western Montana and northern Idaho. Their season tends to start later because it's cooler and the snow in the mountains lasts longer. So we'll keep an eye on that. And I am gonna end with that, and we'll move on to our IOOS partners updates, unless there are any specific questions for me right now. Don't see any questions in the chat, and so I think I will pass it over to Roxanne, unless that's already happened.
You got it.
Like already happened.
Yeah. Thank you. Yeah. Okay, hi everybody, I'm Roxanne Carini, for those of you that don't know me, and I'm not Jan Newton, but I am the Deputy Director of NANOOS, and I'm at the Applied Physics Lab at UW, and presenting on behalf of Jan and many others who either collect this data or make the summary slides every month. I'm mostly focusing on Washington and Oregon, but you'll be able to see the whole West Coast. This is a snapshot from the NANOOS climatology app. I won't emphasize the El Nino signal that we just heard about, but what you can see also in this, in the water temperature anomaly, is that sea surface temperatures were slightly warmer than average right along the coast, as opposed to kind of more average further out just a bit, as I highlighted with the yellow circles. And if we go from January to February to March, you kind of see the same thing, though it gets less and less. If we kind of check on what that looks like from the marine heat wave tracker, which identifies areas where the sea surface temperature exceeds 2 standard deviations for at least 5 consecutive days, we do see some spots that qualify as marine heat waves moderately, like along Vancouver Island and a little bit along the coast of Washington, but nothing out further. And this was at least pulled in April, earlier this month. Here is the NDBC Washington buoy. It's about 300 nautical miles offshore. You can see it on the map on the left. And we're plotting the seasonal mean in black and the standard deviation curves in pink and then 2 in red. And that's from the available record of 45 years of data. Sea surface temperatures were mostly average January through March and into April, with some events that were slightly warmer than average, but not peaking above 1 standard deviation. But here are 4 other buoys, all closer to shore. They're marked on the map on the right and from north to south and kind of color-coded with a little dot at the top of the plots. Again, all the seasonal means were created from the available record, which varies by buoy, but is also labeled. All of these coastal buoys are showing warmer waters than the offshore buoy and hover around 1 standard deviation above average for each site, at times peaking to 2 standard deviations or more above average. And this echoes what we saw in those satellite sea surface temperature anomalies, with the strongest anomalies happening closest to shore. The NANOOS climatology app also serves some wave data from NDBC and CDIP buoys. And what you're seeing here is that NDBC Washington buoy, and kind of without doing any further analysis, it looks mostly like the wave heights are average for the January through into April time period, though there are several big storms that came through. And the coastal buoys, the same ones are highlighted here as before, and they kind of show a similar story. There's nothing that I really want to point out specifically. If we take a quick peek inside Puget Sound, here I'm showing two of the profiling moorings from our orca moorings, one in Hood Canal on the left, and then one in the main basin of Puget Sound on the right. Both are showing warmer than average water throughout the water column, though you can see the impact of a winter storm that was January 13th through 16th in Hood Canal that blew cooler than average freshwater input there in January. For salinity, we're seeing saltier than average waters at both stations, with the exception of the winter storm in Hood Canal, which brings fresher than average, and some other small rain events at both sites. And then dissolved oxygen anomalies, my takeaway from this plot is that they're strong in either direction, in both directions. But I wanted to also show the actual oxygen, just to be clear that while we do see lower dissolved oxygen values in Hood Canal, which is kind of typical for that system, than we do in the main basin, we're not seeing any hypoxia. So hypoxia would be where that color bar in the inset plot turns to white and then purple below, kind of like the color your lips would turn if you were without oxygen. And we're not seeing that at either site. So that's great for January through March and April. Speaking of hypoxia, I just wanted to take a moment and highlight a recent publication in Nature Scientific Reports by NANOOS PI and OSU professor Jack Barth. So this Barth et al. Paper highlights widespread and increasing near-bottom hypoxia along the Pacific Northwest coast. There's maps of near-bottom oxygen since 1950 that show a consistent trend toward lower oxygen levels over time. And this widespread and increasing near-bottom hypoxia is consistent with increased upwelling favorable wind forcing under climate change, right? The paper acknowledges NANOOS and IU's support for some of the glider observations. The Washington Shelf glider in the cyan on the right is supported by NANOOS, and the Trinidad Head glider that's co-supported by CeNCOOS and NANOOS is just kind of at the edge of where this study was focused, but just to let you know that it's down there. I think that this is a great example of how data and information that's being used kind of in the real time to inform tribal and state coastal managers can also be sustained and then reveal changes in the ecosystem that kind of influence adaptation strategies over like a longer term time series. And so I did want to highlight the Trinidad Head glider, and maybe Alex will also talk about this. And it's also run by Jack Barth. And just to show some DO currently, so these are transects from that line down kind of just inside California, onshore to offshore, and same kind of color bar for the dissolved oxygen. So where you see the white show up is that distinction where the conditions flip to be hypoxic, and purple would be very hypoxic or anoxic. And I think this is kind of, these are transects for December and January, February, and all the way through March. And that's kind of the normal hypoxic water that sits below the 350 to 400 meter depth. But we may be starting to see some of the stronger upwelling for the summer season in the final plot for March, kind of if you see the white demarcation kind of starting to slope upwards as it hits the shelf break. But further north, the Washington Shelf glider should be deployed again sometime in May, and that would be monitoring DO upwelled water on the shelf, hopefully continuing to monitor throughout the summer. And so that really will get us up onto the shelf off the coast of Washington and monitoring our Pacific Northwest upwelling signal there. Checking in on blooms and HABs, the ocean color MODIS product as a proxy for chlorophyll A shows kind of little activity along the Washington coast in February. There's like a little bit of green that shows up there showing more than average, but otherwise not much action on the Pacific Northwest. And the Pacific Northwest HABs Bulletin, which was released on April 2nd, and is a collaboration amongst lots of folks. You can see the logos in the top right. Likewise shows low hab risk and really no domoic acid detected in the samples taken along the coast of Oregon and Washington. So to summarize, we've got the transition out of El Nino. We're seeing a stronger signal of warmer waters near the coast than offshore. The wave conditions were about average with some storms as expected for this part of the winter into spring. And Puget Sound's got temperature and salinity anomalies that are warm and salty. There was a mid-January storm that brought some cooler, fresher waters through and higher oxygen conditions, especially in the main basin. And then coastal dissolved oxygen, we're going to continue to track. We haven't really presented our glider data here before, so we're kind of excited to start doing that more consistently and follow on with what CeNCOOS and SCCOOS do there. And then chlorophyll and HABs, the satellites show mostly lower than average ocean color values in January through March, and there's a very low HAB risk with no domoic acid in samples. So that's it for NANOOS. Thank you.
Thanks, Roxanne. I don't see any questions right now, so we'll continue to move down the coast to Alex.
Hi, can you see my slides?
Yes.
Okay, great. Well, wonderful. Thanks again so much for having us. I'm Alex Harper with the Central and Northern California Ocean Observing System. Excuse me, I sit up at Cal Poly Humboldt at the Trinidad Marine Station, and happy to provide our report today. Right to the right. Here we go. Wonderful. So some updates from the region, similar to Roxanne and the folks in the Pacific Northwest. We're sort of closely tracking the onset of the spring upwelling season, which appears to be beginning. And I was trying to get a video to play there of these sort of typical northwesterly winds that are becoming more persistent across the state, and so the conditions are increasingly ripe for upwelling season to begin. Backed by popular demand, there's a histogram in the bottom left of large wave events across the last 30 days, and so certainly some wave activity, but not as many of these big wave events as was previously reported this winter. In the middle is a cool report I saw from our friends at the California Current Integrated Ecosystem Assessment, and along the lines of some of the ecosystem level and information delivered for management and decision making that Roxanne mentioned. Thinking about how we can use some of the data and information being presented today to enhance resilience across different stakeholder groups. So here looking at the fishing fleet across the West Coast and these sort of higher risk areas in Northern California to the Pacific Northwest. And so through some work supported by California Sea Grant, I'm funded specifically to try to deliver climate level information to the fishing fleet, and wondering if there are more opportunities to partner across the NOAA family sort of involved in Westwatch and elsewhere to do that type of work. And of course, you know, with climate driving these ecosystem level changes, including contributing to another year of salmon fishery closure and these strange by the wind sailors, the velellas showing up across the central coast. So something a bit different today, I've pulled some climate indicators again from the folks at the CCIEA, just demonstrating the sort of intensity of the summer heat wave, a bit prolonged likely by the strong El Nino conditions, but appear to be waning in recent months, and so keeping an eye on this transition period and spring upwelling again. But another look back at 2023, these marine heat waves that were sort of augmented by El Nino conditions, and so there were a number of key places along the West Coast that exceeded some previous heat records. And here sort of highlighting a couple of these mini blobs, perhaps, areas of persistent heat off of Northern California and then in Southern California. And this is work that was led by our colleague, Andrew Lysine, who highlighted for us. And then, of course, on the right, our CeNCOOS heat tracker product. Again, both of these products just providing a bit more higher resolution information on marine heat waves, and our tracker even has a forecast into a few days, but generally looking pretty clear of heat waves across the region. Let's see if I can just move this. Okay, so here we're looking at some of our coastal moorings maintained by folks at National Data Buoy Center and CDIP. Looking back, and so these are heat anomaly plots, the sort of red and indicating anomalously hot conditions, blue anomalously cool, and then the higher the bar, the sort of more the more different it is from previous years, so the more anomalous it is. And so looking back over the past year, it's been hot, but particularly so sort of into the fall, likely again contributed to by this strong El Nino. But there is sort of a glimmer of sort of waning conditions. You see up in Humboldt Bay, a bit of blue, a bit of cool water has appeared off the coast. And then looking even further inshore at some of our shore stations in Trinidad, Bodega Bay, and then Moss Landing Marine Lab station in Monterey Bay, we are seeing some blue, some cooler conditions in recent days. So perhaps the very start of the spring upwelling season. I'm excited to present here all three of our continuous glider transects. So we usually don't show Point Arena. And we finally have a long enough time series to begin to generate these plots, which is exciting to look at these three regions from Trinidad to Mendocino Coast and down to Monterey, although do note the time scales. And so we're seeing continuously warm waters down on the Central Coast and up into Mendocino, but cooler conditions off of Trinidad. And then here's some more subsurface data from the Monterey Bay spray glider that's maintained by the folks down at UCSD, looking at the past 3 months, and again, just still warm conditions at the surface in particular, and very little indication of upwelling on the Central Coast. And then lastly, just to punctuate the upwelling, tracking a bit more these figures of cutie and beauty, and we've really been experiencing significant downwelling over the past many months, but we'll be watching this as things transition also. And that's all I have for today. Thanks again.
Thanks, Alex. Gonna head further down the coast to Clarissa, and I don't think I saw, still no questions yet in the chat. So take it away, Clarissa.
Yeah, have you pinged the sharing at me?
I haven't, but I think Joe is running that.
Yeah. All right. See if this goes better than last time. How's that looking?
That looks good.
Okay, great. Yeah, so we're now in Southern California, and I'm Clarissa Anderson. I sit at Scripps representing SCCOOS. I will punt this over to my colleague Jim Behrens at the end to talk about some of the CDIP trends. But yeah, so moving into our show here, we first just wanted to advertise a few things. We're not talking about papers here. We're talking about lots of interesting and I think relevant conferences coming up for this community. Many of you have heard the hype on the Ocean Observing celebration that we're having this May. We certainly have a lot of attendance already on the record, so we're pretty excited about this to celebrate Cal Coffee, SCCOOS, and CeNCOOS long-term observing in California current. I also want to call attention to the fact that it's the 70th anniversary of the Eastern Pacific Ocean Conference. This is one that's also near to my heart. I sit as the president of EPOC for some years now, and we are really used to be more of a combination of NOAA and kind of external or academic partners coming together to talk about Eastern Pacific oceanography. We want to reinvigorate this. It's been an incredible 70 years of getting together and talking about science. So please have this on your radar and come join us at Timberline Lodge on Mount Hood. And I also want to point out this US CLIVAR one that's coming up in September, which dovetails with IUS, has many IUS partners organizing it. And this is related to detecting the climate signal in the ocean, which is what we're doing every time we come to this webinar and show you our data. So I'll jump into the meat, and I'm going to focus our winter to spring update on El Nino and as it transitioned from peak to neutral modes. So MOSI, which you see here on the right in these plots, it's been reported on before in this forum by CeNCOOS. I don't think, Alex, you showed it this time so much, but it rolls up indices like the MEI, PDO, and PGO, and creates this meta index that tracks the ecosystem response in California current to low frequency variability. And you can see some peak positive values in red there on the right in the latest calculation. And that's in step with the peak of this year's El Nino. The value is not as high as seen during some of the previous years, like during the blob years in 2015 or during the 97 El Nino, but they are anomalously high, and this will speak to changes in biological populations, as MOSI has shown, and that may even manifest later because we're used to these lags that it can take quite a long time for the food web to catch up in terms of response to an El Nino. The GRIST product, which you've shown before, tracks the sea surface temperature changes throughout the California current system. Here we're just showing southern component with large departures from the mean at the height of the El Nino in the winter, and then you can track this and see that relative cooling into February, March, and April, as has already been shown by others. I will jump into the spray glider work, just as Alex highlighted some nice glider data. This is coming from line 90, so this is a southern line off of Dana Point. Not mapping it here, but most of you know that geography. And these are an excellent source of subsurface information for the heat content or the large scale changes that we might want to track within the water column associated with atmospheric equatorial forcing, akin to what we see in an El Nino year. So we've shown these Hofmüller diagrams before, like the upper left, where you can see an obvious positive temperature anomaly. It's associated with the late 2023 and early 2024 El Nino changes at 50 meters. And the time series plot at the bottom isolates a temperature index, which is for our local area, the 50-meter glider data, and then compares that with the ONI in order to assess low frequency coupling between the phenomena that we see like ENSO and then our local ocean dynamics. We've shown this coupling before and talked about where the departures happen and how that's interesting. In June 2023, those lines were really in sync. So if you look at the zoom in section on the right, you can see just how by early 2024, those things start to change, the local or the regional peak in black in temperature anomalies lags the peak at the equator, and it's now trending towards ENSO neutral conditions. So we'll have to keep tracking this. But it's always pretty interesting to see how these two phenomena track fairly closely, this time uncharacteristically so in June of 2023, when we saw such a tight coupling between what was happening at the equator and what was happening here locally in Southern California. There are some interesting phenomena being captured by these spray gliders, that some of which I think do relate to El Nino and some of which don't. So the first two slides on the left, what we're seeing here is that the water is anomalously cold and fresh on those shallow isopycnals. So here's 25.3 sigma density layer, and then hot and salty on the deeper isopycnals, which typically we look at the 26 sigma layer for that. And that change to colder, fresher water on those shallow isopycnals really started as early as in early 2023. So well preceding changes at the equator associated with El Nino. And then the hot and salty deeper isopycnals that you're seeing in that middle diagram is more of a decadal signal, according to Dan Rudnick, who collects these spray glider data and has been helping me translate them. And he says this is one of the most striking things on record. So interesting thing we're trying to track, and his team is trying to better understand that. And in general, those temperature and salinity changes that we're seeing that have these sort of longer term trends are really interesting. And they do suggest different sources of water. So when you have these like warmer, saltier, or what we call spicy waters, that's really generally coming more from the south. Those mintier waters, fresher, colder, are generally coming from the north, maybe subarctic source. Then the third plot on the right illustrates an expected response this year to the El Nino that we're having by showing the depth anomaly of these density surfaces. So looking at the 26 sigma layer again, and that band of red at the top is the is showing you that that 26 sigma layer is anomalously deep compared to the mean. This suggests that we're seeing the sort of depression of isopycnals that we, and of the pycnocline that we expect during El Nino years, and this can have huge ramifications on biology. We're kind of, I think, waiting with bated breath going into the spring season to think about what that biological response means in terms of the spring upwelling season. When you have these depressed pycnoclines or thermoclines going into an upwell season, you tend to then upwell lower nutrient water into the surface layer, thereby changing the dynamics of the biology and the plankton response. So looking at the temperature time series at our fixed shore stations, this is different from the glider time series. You can see some dramatic heating at the surface in December 2023, followed by kind of intermittent cooling and heating as we go throughout the winter and into the upwelling season. And then at the end of March, there's fairly consistently cold water at the surface on the shelf. I just want to point out, though, that our time series at Santa Monica is a little compromised because we've had quite a lot of water quality issues there, and the sensors have been down. But these trends seem to be fairly consistent across our various shore stations in Southern California. And salinity is really interesting. So if you look at the salinity time series at those same shore stations, much as we saw with the glider time series, the shallow waters are fairly uniformly freshened with respect to the mean. And maybe this isn't weird. I mean, over the December to April timeframe, we saw a lot of storms. You would imagine there would be some nearshore freshening, but as we go into the upwelling season and we start to see that signal in the temperature, which is really reflective of upwelling, we're not really seeing it so much in the salinity time series here. So just like with the gliders, this could be reflective of some kind of northern source of water that's coming in at the surface anyway. And I'm going to shift to some biology for my last slide. Roxanne touched on harmful algal blooms as well, and I'd like to just point out that there's always this expectation as we go into an El Nino year that there might be a harmful algal bloom. I'm not sure that really stands up relative to the data and the trends we've seen in the past. But what I'm showing you here on the left is an animation of sea harm. It's displaying the likelihood of the risk of high domoic acid. That's a really potent, deadly neurotoxin that Roxanne mentioned. Is produced by the diatom Subnichia. So you're seeing a time series there on the right. But I want to also say that with the animation, it's a little confusing when you see some of these elevated probabilities in red at times when we're not really sure that it could be linked to upwelling. But sometimes storms, particularly winter storms, can create quite a lot of turbidity in the surface layer in the right along the coast in the coastal zone, and you get some interference in that 555 nanometer band, which is used in this model, and that can kind of skew things towards false positives. But we do see a really increasing trend towards higher probability of domoic acid going into the spring season, and that's reflected in the time series on the right from HADMAP, which show you the more toxigenic group of that diatom. And when you look at the dotted line is showing you what those bloom levels are. So those bloom levels were reached or exceeded at all stations with an early and vigorous onset in Southern California all the way up to Santa Barbara. We definitely see it though in Central California as well. This doesn't necessarily mean that we're going to have a HAB in response specifically to the El Nino. This is also spring upwelling season when we see phytoplankton blooms and harmful algal blooms, but we're already seeing some marine mammals stranding from domoic acid-like symptoms in Central California around Santa Barbara. So this could possibly signify an offshore toxic event pretty early in the season. And now I'm going to push it to Jim and advance the slide here.
Thanks, Clarissa. The view from CDIP over here, a lot of this is consistent with some of the other reports, but the West Coast wave activity has generally been within the climate expectations. We had some notable long period El Nino type powerful swells that hit, in particular up there at Grays Harbor, one of our longest tenured stations. That 9+ meter HS in early January was a top 10 all-time swell event for that area. But then throughout the rest of the region through the winter, the atmospheric river activity in early February dominated in Central California region, and those are shorter periods, tends to be at around 11 seconds peak period instead of these El Nino swells, which are more like 14, 15 seconds. And then down in Southern California, again, you can see the atmospheric river activity in February, but things have been generally within expectations and not too extreme. Next slide, please. This is a look at some of the temperatures. Again, Grays Harbor, we're seeing, as was mentioned earlier, the heat up there continues, and down in the bites, we didn't see much deviation from the mean actually at San Pedro. A bit of a detachment from the rest of the behavior along the coast. And then I'll just wrap up by mentioning we have some new stations coming. There'll be a pair of them installed off of Newport, Oregon, most likely next week as part of an NREL wave energy test site, PAC-WAVE. And then we're also working towards a deployment in the Monterey Bay area for helping us understand the local seas information with some of the erosion and coastal processes work that we're partnered with in that region coming up. So CDIP 156 Monterey Bay is likely to return. So that's it from here. Thanks.
All right, well, thanks everyone so much for the updates as usual. That was all great. I still don't see any questions. We have a few minutes remaining, about 6 minutes. If anyone wants to ask a question, you can type that in the chat, or I'm not sure if you can unmute yourself, but you can give that a try. Or if any of the other speakers have anything, discussion points you'd like to bring up, we do have a few minutes remaining.
First, I just wanted to know the origin of salty and minty water because I like that terminology. Spicy and minty water, sorry.
I like that.
It's widely used by oceanographers, and it's a good way to track, water masses by this sort of when you're looking at the temperature salinity plot, which we always do to look at water masses. They came up with these some time ago.
I've always seen it labeled as like A, B, C, and like corresponding to where it came from, but I much prefer salty or spicy and minty.
I identify with the spicy water.
And Joe, I don't know if we have a next West Watch set or not, but if we do, maybe we can announce it. If not, that's fine too.
Yes, and I can't recall the date right now. I think it's still sticking with the third Tuesday. But we're going to be hearing from Troy Nicolini, who's the meteorologist in charge for the Eureka WFO, and he's going to talk about a project that he's worked on with folks at NOAA Fisheries for looking at seasonal forecasts and how that they were able to use those to make watershed restoration decisions. Kind of could they be working in the watershed or not if a big storm was on its way. So look out for the invite for that in the next few weeks. And we are also a little bit backlogged in getting our videos up. We've got January up, but not the last couple, but I'm hoping to fix that very soon.
Great, thanks for that update, Joe. Anything else? Last chance. Or we can cut out a couple minutes early. All right, small and quiet group today. All right, well, thank you all again so much and look forward to hearing from everyone on the next West Watch.